Welcome back to Solve It with Sir Jude. Today we will be discussing about properties and graph of a quadratic function. So what are the different properties that we are to consider when we are dealing about quadratic function? And how are we going to draw the graph of a quadratic function? So let us consider the following properties of a quadratic function. So the opening of the graph, the vertex of the graph, the axis of symmetry, the x-intercepts, the y-intercept, the domain, and the range. So these are some of the properties that we need when we are dealing with quadratic function. So actually, when we are dealing with the properties, it is related to the graph of a quadratic function. So let us start with the first given. Given the quadratic function y is equal to x squared minus 6x plus 5, let us determine the properties and the graph of this quadratic function. So we will be dealing and finding the 7 properties. So when can we say that a parabola opens upward and a parabola opens downward? So it will depend on the value of a. So if a is greater than 0, meaning that the value is positive, the parabola will open upward. Okay? And since the parabola opens upward, the vertex of the parabola will be at its minimum point. So therefore, the function will have the minimum value. If the value of a is less than 0, meaning that it is a negative number, the parabola now will open downward. So since the parabola opens downward, the vertex will be at its maximum point. So therefore, the function will have the maximum value. So given this quadratic function, the value of a here is positive 1. So therefore, we can say that the parabola will open upward. And then, since it opens upward, it will have the minimum value. So after getting the opening of the graph, let us now consider the vertex of the graph. So the vertex of the graph of a quadratic function, it refers to the highest and lowest point of the graph or the parabola. So there are formulas that we need to consider. The formula in getting the value of h, which is negative b over 2a. And for the value of k, we will be considering 2. But either of this formula will work and will have the same answer. So we have k equals c minus b squared over 4a. And the other one is 4ac minus b squared all over 4a. So they are just the same. So in getting the values of h and k, we need the values of a, b, and c first. So given this quadratic function, the value of a is 1, the value of b is negative 6, and the value of c is 5. Then we need to substitute. So h is equal to negative b over 2a, substituting the values of a, b, and c, or a and b in this variable h, we have h is equal to negative of negative 6 over 2 times 1. Negative 6 since the value of b is negative 6, and 1 since the value of a is 1. So simplifying this, negative times negative 6, that will be positive 6. 2 times 1, that will be positive 2. So therefore, h is equal to 3. So let us now get the value of k. Let us substitute the values of a, b, and c. So the value of c is 5 minus b squared. The value of b is negative 6. Then square it over 4 times 1, which is the value of a. Then simplifying, negative 6 squared is 36. 4 times 1 is 4. Now we have k equals 5 minus 36 over 4. 36 divided by 4 is 9. Thus, we have k equals 5 minus 9. And then 5 minus 9 will give us negative 4. So since the parabola opens upward and it will have a minimum value, we can find the minimum value using the value of k. So therefore, this quadratic function y is equal to x squared minus 6x plus 5 will have a minimum value of negative 4. So if we are going to combine 3 and negative 4 and make it an ordered pair, we can now formulate our vertex. So the vertex will lie at 3, negative 4. Okay, so we are through in finding the vertex. Let us now find the axis of symmetry. So when we talk about the axis of symmetry, it is the vertical line that passes through the vertex and divides the parabola into 2 equal parts. And it is described by the equation x is equal to h. Remember, we already computed or solved for the value of h. The value of h here is positive 3. So therefore, the equation of our axis of symmetry later in the graph will be x is equal to positive 3. So we are through with the axis of symmetry. Let us now go to the x-intercepts. So when we talk about the x-intercepts, so these are points in the form of x comma 0. These refer to the values of x when y is equal to 0. So therefore, out of the given quadratic function, y is equal to x squared minus 6x plus 5, we just need to change the value of y to 0. Okay? And then get the values of x. So this equation can be transformed to x squared minus 6x plus 5. The third form will be x minus 5 times x minus 1 is equal to 0. Okay? So that is using factoring. Then using your zero product property or applying the zero product property, equating both factors to 0, the first value of x using x minus 5 is equal to 0, we have x is equal to 5. While the other value of x will be x equals 1. So also x-intercept is also known as the zeros of the function. So since we already computed and solved for the x-intercepts, let us change this one in coordinate form or ordered pair. So we will be following x comma 0. We will just need to substitute the values of x and replace with the variable x here in the ordered pair. So therefore, the first ordered pair will be 5 comma 0, and then the other one is 1 comma 0. So after getting the x-intercepts, let us now have the y-intercept. So the y-intercept is a point in the form of 0 comma y, and it refers to the value of y when x is equal to 0. So if it is x-intercept, the value of y is 0. But if we are talking about the y-intercept, the value of x here now is equal to 0. Okay? So y is equal to x squared minus 6x plus 5. Since we are looking for the y-intercept, we just need to change all those x variables by 0. Okay? So simplifying this equation, we now have y is equal to 5. But if the equation is written in its standard form, we can use y is equal to c. We just need to get the value of c, then that will be the value of the y-intercept, or the y, the value of y. So changing this one in ordered pair form, or 0 comma y, the ordered pair will be 0 comma 5. So we now have there 4 points. So in order for us to plot the graph of a quadratic function or a parabola, we need 5 points. Okay? So to have its accurateness and preciseness of the graph. So if you can see, we already have here 4 points. The vertex, the 2 x-intercepts, and then the y-intercepts. So let us now graph our parabola. So this is the Cartesian plane. So the first thing that we should do is to plot the vertex. So this is the vertex that is labeled 3 comma negative 4. And then let us now have the x-intercepts, 5 comma 0 and 1 comma 0. So this is 1 comma 0 and this is 5 comma 0. So when we are plotting the x-intercepts, they are located on the x-axis. So then we plot the y-intercept 0 comma 5. So this is 0 comma 5. So unlike the x-intercepts which are located on the x-axis, for the y-intercept, it is located on the y-axis. Okay, so if you can see, we have here 4 points. Let us determine the other point for us to have 5 points. So we will be using the axis of symmetry that has the equation x is equal to 3. How are we going to determine the other point for us to have 5 points for the accuracy of the graph? So if you can see, the x-intercepts 1 comma 0 and 5 comma 0 are of equal distances with respect to the axis of symmetry. So from 1 comma 0, there are 2 units to make it to the axis of symmetry. So that will also be the same for 5 comma 0. So from 5 comma 0, 2 units to make it to the axis of symmetry. So the same concept will be applied in order for us to get the reflection or the symmetric point to 0 comma 5. So the axis of symmetry can serve as a mirror. So 1 comma 0, the reflection is 5 comma 0. So our task is to determine the a reflection of 0, 5, or the point that is symmetric to 0, 5. So how are we going to do that? So we need to count from this point 0, 5 how many units to the axis of symmetry. And if you can see, if we are going to count, so there are 3 units from this point to the axis of symmetry. So therefore, to reflect the point to the other side of the parabola, from the axis of symmetry, we need to count 3 units also to the other side of the parabola. Okay? So therefore, we now have here the reflection of 0, 5. So what is the name or the label of this point? So this can be labeled as 6, 5. So since we already have there 5 points, we can connect them and form a parabola that opens upward. So the label or the name of this parabola is y is equal to x squared minus 6x plus 5. Okay, so we already have the graph of our quadratic function. Then, let us have the domain. So when we talk about the domain, these are the set of possible values of x. Since the parabola, our parabola that opens upward and downward, extends from left to right, the domain of a quadratic function will be the set of all real numbers. So this will be true to all quadratic function. Okay? So next, for the range, since the domain is the set of all possible values of x, for the range, it is the set of all possible values of y. But in this time, we need to consider the following conditions. So if the value of a is greater than 0, meaning it is positive, then we will be using this notation. All y's or all values of y such that y is greater than or equal to k. And if the value of a is less than 0, meaning it is negative, then we will be using the second notation. We have y such that y is less than or equal to k. Since the value of our a here is 1, so therefore we can use the first notation, y such that y is greater than or equal to k. Take note that we already solved for the value of k, which is located in our vertex of the graph, -4. So therefore, the possible values of y here, given the quadratic function, is all values of y such that y is greater than or equal to -4. Okay? Or in other words, that will be from -4 up to the positive infinity. Okay? So let us now proceed with the second example. So let us now determine the properties and the graph of this quadratic function. So we are given with y is equal to -x squared plus 4x minus 3. So let us determine the opening of the graph for this one. So the opening of the graph is determined by the value of a. So if the value of a is positive, it opens upward. If it is negative, it opens downward. Since the value of a here is -1, so therefore we can say that the parabola will open downward. Since it opened downward, the vertex will be at its maximum point. So therefore, the quadratic function will have the maximum value. Okay? So we are through with the opening of the graph. So let us now go with the vertex of the graph. So using again the values of h and k, or the formula for h and k, and determining the values of a, b, and c. Let us substitute the values of a and b to this formula, -b over 2a. So we now have -4 over 2 times -1, which will have -4 over -2. -4 divided by -2, that will give us +2. Okay? And for the value of k, so that will be -3 minus 4 squared over 4 times -1. And simplifying, so that will give us -3 minus 16 over -4. 16 divided by -4 will give us -4. Negative times -4 will now produce +4. Thus, we have k is equal to -3 plus 4. And then, -3 plus 4, that will be +1. Okay? Since the opening of the graph is downward and it has the maximum point for the vertex, so therefore, it will have the maximum value. So what will be the maximum value? The maximum value will be determined by the value of k. So the maximum value is 1. So if we are going to combine h and k in one ordered pair, we can have the vertex. The vertex of the graph will be at 2, 1. So let us now proceed with the axis of symmetry. The axis of symmetry is again a line determined by x equals h. We already have the value of h. We already solved it a while ago. So that will be x equals 2. Since the value of h is 2. So it can be seen in our vertex. So next, for the x-intercepts, we just need to let y be equal to 0. So from our quadratic function, letting y to 0, that will be 0 is equal to negative x squared plus 4x minus 5. It's easier to factor if the value of a is positive. So let us make this negative value of a be positive. So how are we going to do that? We multiply all the terms by negative 1. So if we are going to multiply and distribute negative 1 to all the terms inside the parentheses, so we will now have x squared minus 4x plus 3 is equal to 0. And then factoring this trinomial, we now have x minus 3 times x minus 1 is equal to 0. Then, applying the zero product property, equating both factors to 0, the first value of x is 3, and then the second value of x is 1. So these are the x-intercepts or the zeros of the function. Let us turn it into an ordered pair. So for x equals 3, the first ordered pair will be 3, 0. And then for the other value of x, we now have the ordered pair 1, 0. So after computing the x-intercepts, let us now compute and solve for the value of the y-intercept. And if you can see, the quadratic function is in standard form, so therefore, we just only need to get the value of c. And that will be our y-intercept. Okay? Turning this one into an ordered pair form 0, y, it will be 0, negative 3. So let us now graph. If you can see, we now have 4 points. The vertex, the two x-intercepts, and the y-intercept. So first, let us plot the vertex 2, 1, and then the x-intercepts 3, 0, and 1, 0. Then, the y-intercept, which is 0, negative 3. So, we only have 4 points. We still need to find another point. So, to find the other point or the reflection, we need your axis of symmetry. Okay? Which has the equation x is equal to 2. So, aside from counting how many units is the given point to the axis of symmetry, there is another way. We need to choose a point in the x-axis that is symmetrical to this point. Okay, so in this case, let us use x is equal to 4. So out of y is equal to negative x squared plus 4x minus 3. Remember that if it is quadratic function, we can replace y by f of x. And then substituting the value of x, which is 4 that we have chosen a while ago. So that will be f of 4 is equal to negative 4 squared plus 4 times 4 minus 3. Okay? And negative of 4 squared, that will just be negative 16 plus 4 times 4, that will be 16 also minus 3. 16 minus 16 is 0. 0 minus 3, that will be negative 3. So therefore, if x is equal to 4, therefore the value of y is negative 3. Okay? So if you can see, if we count, we still be arriving at the same point. The location of the point, rather. And then let us now draw the parabola, and the parabola opens downward. And the name of this parabola will be y is equal to negative x squared plus 4x minus 3. So for the domain of this function, it is said to be all real numbers. And for the range, we will be considering the two conditions which will satisfy. Since the value of a here is negative 1 or less than 0, we will be using the second notation, y such that y is less than or equal to k. Since the value of k is 1, as we solved it a while ago, so therefore, the range of this function will be y, or all values of y, such that y is less than or equal to 1. And if you can see, the possible values of y will be from 1 down to the negative infinity. So there are times that the number of points are not sufficient for us to graph the function. Like for example, when we are given with a perfect square trinomial. So given y is equal to x squared plus 4x plus 4, so let us try to graph and determine the properties. So for the opening of the graph, since a here is equal to 1, so therefore it opens upward. And the vertex of the graph, so that will be h is equal to negative p over 2a, and k is equal to c minus b squared over 4a. So just a run through. So that the value of b is 4 and the value of a is 1. So we now have h is equal to negative of 4 divided by 2 times 1. So that will now be equal to negative 4 over 2. Negative 4 over 2 is just equal to negative 2. So we now have the value of h. So next, let us have the value of c. So substituting the values of a, b, and c, the value of c here is 4, the value of b is 4 also, and the value of a is 1. So 4 squared is 16, and 4 times 1 will be 4. So now we have 4 minus 16 over 4. 16 divided by 4 is just 4. So we now have k is equal to 4 minus 4 that has a value of 0. Since it opens upward, the vertex will be at its minimum point. So the minimum value can be determined by the value of k. So therefore, the minimum value will be 0. So combining them in one ordered pair, the vertex will be at negative 2, 0. Okay? So the axis of symmetry will be at x is equal to negative 2. So just x is equal to h, since the value of h is negative 2. Therefore, the equation will be x is equal to negative 2. Then for the x-intercepts, if we are going to let y be equal to 0, and factoring, that will just be x plus 2 times x plus 2 is equal to 0. So therefore, the zeros of the function will be equal. We now have x is equal to negative 2. And transforming it to an ordered pair form, so that will now be negative 2, 0. So from this one, the x-intercepts and the vertex of the graph are the same. So let us now have the y-intercept. So for the y-intercept, since we have here the quadratic function written in standard form, we just need to get the value of c. So therefore, we have y is equal to 4. Transforming it to an ordered pair form, so that will be 0, 4. So if you can see, we have here 2 points because the vertex and the x-intercepts are just the same. So let us now graph our function. So if you can see here, the domain is all real numbers and the range is y, such that y is greater than or equal to 0. Greater than or equal to 0 since the value of a is 1. Okay? 0 because the value of k is 0. Okay? So to graph, we need first the vertex of the graph. So that will be negative 2, 0. So this is the vertex. This is also the x-intercept. So the only point left is 0, 4, which is the y-intercept. So this is 0, 4. So this is the axis of symmetry labeled as x is equal to negative 2. And we can actually reflect 0, 4 to the other side of the other half of the parabola. So from this point to the axis of symmetry, there are 2 units. So we will be counting another 2 units from the axis of symmetry this time to the other side of the graph. So that will be 1, 2. So this should be where the other point is located. So the point here is labeled as negative 4, 4. So the next question is, how are we going to determine the other 2 points before connecting those points to make a parabola? So let us choose points in the x-axis that are symmetrical to each other. So let us choose negative 1 and negative 3. Okay? So if the value of x is negative 1, what will be the value of y? So we just need to substitute the value of x in the equation. So that will be y equals negative 1 squared plus 4 times negative 1 plus 4. And if we are going to simplify, we have 1 minus 4 plus 4, which has the answer y equals 1. So therefore, if x is equal to negative 1, the value of y is 1. And that will be our other point. Okay? So this is other point, negative 1, 1. So we already generated the 4th point. You can actually reflect it or you can use this way or this method if x is equal to negative 3 this time. So just substitute negative 3 to x, and substituting the value of y is 1 also. So therefore, if the value of x is negative 3, the value of y is also 1, which has the coordinates negative 3, 1. So this is negative 3, 1. And if you can see, we already have 5 points. Therefore, we can connect and make a parabola. And the parabola will be named as y equals x squared plus 4x plus 4. Okay? So if you've learned something for today about the properties and graph of a quadratic function, do not forget to like, share, hit the notification bell for more video lessons. You may also share this video lesson for us to help other students who are dealing with this particular topic. And do not forget to subscribe if you are a new viewer in our channel. So this is Sir Jude. Good day.